Is anyone here? Hello? Latency seems pretty high if I'm not receiving a response yet. Or it might just be that you can't hear me. So you can't hear me then. Hello? I am reading the YouTube chat, but it seems to be somewhat delayed sometimes. But it might just be my internet being bad. I should read Discord chat? What's in Discord chat? I should read Discord chat? What's in Discord chat? I should read Discord chat? Oh no, the sound is looping again. What's in Discord chat? Oh. Why is technology so difficult? The sound is looping again. Oh. Why is technology so difficult? The sound is looping again. Oh. Why is technology so difficult? The sound is looping again. Oh. I mean, surely you can just live with that. It doesn't seem that bad. I mean, surely you can just live with that. It doesn't seem that bad. I mean, surely you can just live with that. It doesn't seem that bad. I mean, surely you can just live with that. It doesn't seem that bad. That stuff. I think it's because you're playing the stream and the sound from that is being recorded. That would make sense. You're playing stream and the sound from that is being recorded. That would make sense. You're playing stream and the sound from that is being recorded. That would make sense. You're playing stream and the sound from that is being recorded. Let's use Discord. Hello. Where is... Okay, let me just mail that to everyone. But I can't do it in that window because I don't want you to see my emails. Find out how many of them I haven't answered yet. Everyone. It would be a real shame if I leaked any problems. I mean, I probably want this in this window. So if I minimize both of them, I can have them both up. am I doing? Whiteboard. Okay. I guess I'll wait a few more minutes just so that people have some time to trickle in. There are currently 15 people watching. That seems like most people who answered the form. Wow, everyone but one person. So everyone's basically here. Okay. So I haven't really actually prepared anything for this live stream. So I guess we'll see how we go. So my plan was kind of that I wanted to start from the very beginning, because while there's like a lot of more advanced content here that people want more than the less advanced content, I feel like it wouldn't really make sense to go in the order that people actually voted for the topics, because we're kind of jumping around between things. So I'm just going to start at the very beginning. So what I'm actually going to assume that you know about range trees. So is this recording? As I understand it, the answer is yes. I think YouTube streams are automatically recorded. I believe that's correct. Yeah. So I think the first thing I want to start off with is I just want to show you all how to code, how I code a range tree at least. That way you can kind of see how I put things together. Like, I feel like I've coded something like at least 3 range trees over my entire lifetime. So I've kind of got a flow for how I do them. And because it's the same every time, it's really difficult for me to get them wrong. But that being said, I hope I don't actually get something wrong. Okay, let's code a range tree. Oh, I can't just open ORAC because you'll see all the problems. Okay. Oh God. What is the problem that I want? What's the simplest range tree problem called? It's like a really simple one. Min tree 2, that's the one. Yep, let's do that. There we go. Oh God. Okay. Oh no, there's so many messages. That's a meme. That's a meme. That's a meme. They're all memes. Okay, wonderful. Oh God, you can't see that. Oh, I can't just list things because what if there's like a secret? Okay. Cap, kek. Oh, okay, wonderful. All right, time to code a range tree. I don't even know if this is useful. So like, let me know if you want me to do something, because I've never done a live coding thing before, so I have no idea how they work. So if there's something that I could be doing that's better, that would be great. Oh, I'm just looking at the stream preview and it doesn't seem like you can see my entire screen. Is that correct? Several people are typing. We can't see the statement. Oh no, the stream is ruined. Okay, can I fix this live? Is that fixable live? Jesus, okay. Where is it this one? Oh, I can't change this. Oh God. Why is this broken? Why are you like this? Why are you like this? Video output is currently active. Please turn off any outputs to change video settings. Okay. I guess I'll stop streaming for like a bit. I have returned. Have I returned? Is it fixed? Did I fix it? Oh, the preview window looks good. And I'm seeing yeses, but also no's. And a no, but actually yes. That's very helpful. Okay, I'm gonna assume it's fixed because it looks okay in the preview window. All right, so it's time to decode a range tree. What does this range tree do? It needs to be a min tree and answers, and what are the updates? Just change an element. Oh, there's like a billion yeses now. Andy, you fixed it. Wonderful. Okay. Hold on a second. If I just put it here, then can't you see the chat as I see it live? Is that helpful? I don't know. All right, let's try it. Oh, but I need to see what the problem says. Okay, whatever. So a range tree, this is a range tree node. Each node of the range tree needs to have a pointer to its left and right children. I'm going to call them LC and RC for left child and right child. I'm going to use pointers because I find them more intuitive. They're kind of slower, but I just cross my fingers and hope that it's fine. Stick to one channel. Yeah, this one. Are people posting in other channels? Oh my God, there's so many comments that I've missed. 22 is the default SSH port? What does that have to do with anything? Oh, you're trying to SSH into Orac? Are you hacking Orac? That's not allowed. You have to delete this message. How dare you? Let that be an example to the rest of you folk. Could you zoom in on your terminal, please? Did that work? Oh, but it made this bigger, which is weird. Okay. Yeah. I'm gonna be looking at the RT chat mostly. So if you've said things in the general chat, I'm just gonna pretend that I haven't read it. All right. It's a min tree, so we need the minimum. And I think that's all that you need for a range tree. I don't know, it sounds good to me. All right, so now I'm gonna write the constructor. It takes the left and the right, which is the range of the node that we're constructing. I'm going to avoid doing anything too fancy. Is everyone familiar with structs and constructors? Let me know if you're not. I'll quickly explain them. Otherwise, I'll just assume that everything is okay. I mean, it's pretty intuitive what it does anyway, I hope. Okay. FL is okay, wonderful. So whenever you create an object in C++, it needs to be initialized. And depending on the object, you might want to do some special things to it when you initialize it. So the constructor is a special function that gets called whenever you create an object. So whenever I do something like rt star my range tree equals new range tree 110, this creates a range tree object, an rt object, and it initializes it based on this special function, which is called a constructor. And the way that you define a constructor is that you give it, the name of the function has to be the same as the name of the struct. So structs and classes are the same thing. Structs just have different default visibilities. So if you're familiar with classes in C++, you'll understand constructors as well. I've gone on a tangent. But yeah, this is just a fancy way of saying, when I create this object, this is what I want it to do. This is what I want it to be initialized with. Okay, there's more chats, but they're all complaints about using pointers, which I'm going to ignore. All right. Okay, so this is if it's a leaf, then we don't do anything. Otherwise, this equals t mid plus 1, and then I have to find mid. Is there a difference? The live stream is stopped? It's not working for me. Is the live stream broken? What's going on? Well, I mean, if the live stream is broken, then the people for which it's broken wouldn't be able to respond in the chat. So I should write it in the chat. Chen Nivin. Rhino. Is it working? Maybe refresh. Wonderful. Okay, so I'm guessing that it's gonna cut out from time to time because I've set it the stream latency to ultra low latency, which means that you're gonna get occasional buffering. So you might end up being behind at some points, but if it gets particularly bad, maybe you can just refresh the page. But like, just let me know how it's going, and if you're finding that it's really difficult to follow things because things are getting cut or you're several minutes behind, let me know and I'll try to work something out. Okay, back to the range tree. 1, 2. Okay, so with some implementations of range trees, people will calculate the left and the right, like the range that every node covers, and then store that in variables like int L and int R. And that's what I'm gonna do. L equals L and R equals R. So you don't have to store these values as you go. It adds a bit of extra memory that you need a bit of extra memory to do it, but I find it easier because it means I don't have to keep on passing around the range of every node as I call my range tree functions. Hopefully that makes sense. Actually, what implementation did I send to you all? CP algorithms, segment tree. What does CP algorithms do? You sent the rec one. What does that mean? Okay, this is implementation that I think I sent you. So yeah, it looks like in this particular implementation, you can see that they're passing around both the range of the query and also the range of the node that you're currently at, I think. I don't know which way around these are, but I don't like doing that because, I mean, when you look at this, you're like, damn, that's like 5 parameters. That sounds like a lot of parameters. And every time you write a different function, you have to make sure you get all the ranges right. Otherwise, things are screwed. Although now that I look at this, I don't really understand what's going on anymore. Anyway, that's a side detail. So yeah, I would recommend storing them explicitly so that you don't have to calculate them as you go. What am I doing? Yeah, okay, so this is initializing the range tree. So it builds the nodes as you go, and it stops at the leaves. And I think that's okay. So next I'm gonna write the update function, I think. That one's easier, I guess. It's gonna update position X with value V. What is the exact operation? Is it a set? What are the updates? Okay, it's a set. Okay. You can use default parameters, though. Yeah, I guess you can when you're calling it, but internally, don't you still have to set the mids and the lefts and the rights correctly? And yeah, that's a good point. If you don't explicitly set something, then maybe the default isn't actually what you wanted, and that can be hard to spot. Okay. Alright, so there's two cases. Either the update point lies inside the range of the current node or it lies outside the range. If it lies outside the range, less than L, or is less than X, outside range. So we can return without doing anything. Otherwise, if otherwise it's inside the range. So if it's a leaf, then you just set M to be the new value. Otherwise, you call update on the left and on the right. And then you have to set your new value. It's a min tree. RCR. That's actually not at all correct. I don't know why you would allow me to do that. Wonderful. Why is it angry? Oh, right. I can't believe that's not the first thing that I wrote. You can clearly tell I haven't done informatics in a long time. Alright, I think that update function is now correct. So, what's arrow? Okay. So when you're trying to access a pointer, if you want to get the actual object that's being referenced, use the arrow. So if this wasn't a pointer and it was just a normal object, you wouldn't use dot. Okay. And the other operation is sum. I'm just gonna call it query because I call everything query. So the query left range and the query right range. Okay. Okay, so there's three cases. Query misses this node's range. Query dominates this node's range, or it's a partial overlap. Okay, so this one is the easiest one to handle. If the query's right end is less than this node's left, or the query's right end is less than QL. Is that correct? So it's like, this is the query. This is my range. I buy it. Seems good to me. What does dominate? Dominate means it completely covers. Okay, so in this case, we return, so if this is a min tree, then we should return the maximum possible number. So, max. Constant max equals 20. How big can the numbers go? Oh, I'm sure it's probably not that large. Alright. Otherwise, if So domination happens when the query left is less than or equal to my left, and right is less than or equal to my right. And otherwise, we're in the partial overlap case. So in this case, we just return qswitch, ql, and qr for dominate. What does that mean? Who knows? All right. If you didn't use the new keyword, would the pointers get out of scoped as soon as the constructor ended, or at the end of the program? Yeah, if you're gonna format it like this, then as soon as, if you're gonna format it like that, use the new keyword. Do you mean using the new keyword here? So the object that you created by the new pointer, by the new call here, would go out of scope as soon as the struct that you created goes out of scope. So down here, back when I had I've forgotten what I said, but when you do like new range tree 110 or whatever, then anything you create in here will be will not be destructed until this object that I created here gets destructed. Yeah, I think that's a better way of putting it. When you create something with new, it never ever gets destroyed. But as soon as you lose the reference to it, you can kind of think of it as if you'll never get it back. Yeah. I feel like I'm getting a bit sidetracked here with pointer related things. Okay, let me just quickly finish this off. So if it dominates, then you just return this nose value. Otherwise, you return min of and Roger. And I think that's it. Oh, it seems right to me. All right, let me quickly speed through the IO. Okay. Main NQ. T from 0. Oh, it's 1 indexed. Okay. Why not? Just want that. So I forgot to set M here. I guess by default we'll just set it to max. RT update. What was I doing? No, it's position first. So it should be that. Okay. So yeah, the way that I typically like to initialize my range trees is to just initialize everything to the default like null value and then use my update function to actually put the values in. You can kind of shortcut this by instead reading in the array and here doing m equals a of not in here, but like in here. M equals a of L. And then performing the update logic inside here to like this thing. Oh God. Putting this in here. But I don't like doing it that way because I feel like it's less elegant. Even though it's more efficient in terms of both in terms of time complexity and in practice, but it usually doesn't matter. What was this before? I don't remember. There we go, I think. Okay, and now actually have to handle the queries. Let's look at it. If equals q. If it's a query, then just print that, I'm guessing. And otherwise, why are you angry? P1 is uninitialized. This is why you should use compiler flags like -wall and whatnot. And we get a new line as well. Otherwise, oh, you don't print anything. Why am I trying to do that? Linting is amazing. Yes, linting is awesome. I would definitely use an IDE if any of them had really good Vim bindings, but they don't. I think that this just works. I buy it, we could go wrong. And I think that's it. Okay. Vim cupcake. Alright, that seems pretty good to me. I've solved this before. Oh, wonderful. Alright. Oh god! Okay. Good thing nothing bad happened. That could have been very bad. Okay. Where is... You don't have to worry that it's buffering because I haven't figured out where I've actually put the code. Okay. Alright. Oh, that's a good sign. Oh no, but it's real slow. It's very slow. Okay, fine. Maybe you're right, Max. I should put that line in. Oh geez, it's very slow. Oh, that's true. You can't use cin and cout on Orac. That's such a rip. Okay. What is the command? You want me to do that and alright. Judging area locked. Oh no. Please. Oh, have I cooked myself? Okay, I may have cooked my account on the training site by doing that, but I'm sure if I just wait like 17 seconds or whatever, it'll be fine. So in the meantime, I'm gonna augment this range tree and make it one of those lazy range trees. Vim R2. Okay. Lazy. Okay, so this time I'm going to change the update so that it takes in a range. So instead of this, it's UL and UR. So what this does is it takes a range and it sets everything in that range to V. YOLO submit and then test while judging. That's unfortunate. Okay. Okay, so this time we're going to need to do some lazy propagation to be able to facilitate operations that update our range. Is someone trying to ping me? It doesn't give time penalties for additional attempts. Resubmit. I really don't want to miss this. I don't know if there's anything that I'm supposed to have read here. Okay. I mean, it just seems like more memes. I can't use that other word on stream. Okay, so in order to be able to facilitate this, we need a dirty flag. Okay. Okay, so the convention I'm going to use here is that if dirty equals max, that means nothing to do. So I'm going to set dirty to max if there's nothing to do. Well, I call it dirty because the idea is that every time you enter one of your range tree functions, you don't want your current node to be dirty. Because like in real life, if you enter a dirty room, your immediate thought is, I would like this to be clean. But the analogy doesn't make as much sense for like a lazy. Like I can't think of something similar to that. Yeah, okay, so how does update change? I'm just gonna delete this all. Well, maybe I'll keep it here so you can see how it changes. Okay, so again, this looks a lot like a query function so far. So if it completely misses the range, we don't care at all. Otherwise, if it completely dominates the range, oh, I went too far. Is this fixed yet? Have I cooked myself? Okay, maybe if I just submit again, it'll be fine. Wonderful. Okay. I wonder what the other word is. Ha 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 ha. I would like this to be clean. Oh, look at that. It works. That's awesome. Okay, so I have received my validation for the day and I can now close the stream. Why are there subtasks to this problem? No updates, only queries. Okay. What was I doing? I was updating. Okay. Oh, that's right. I was just copying the other function. Because it's pretty much the same anyway. Okay, so if you completely subsume the range, then all you need to do is set dirty equals the thing you're changing it to. And you can call it a day. Otherwise, you kind of do the normal range tree things. UL, you are. Is this line still necessary? I think the answer is no, it's not. I don't know. Okay. So that's that, I think. Oh, you have to be careful to make sure this isn't a leaf. Not a leaf. But we know it's not a leaf because otherwise it would have been covered by one of these other two cases. Okay. So the idea is that because we know that this update covers this node's entire range, the update would apply to everything in this subtree. But instead of doing that right now, we can just say, all right, the next time we come to update this subtree, or the next time we come to query this subtree, only then will we deal with actually pushing down the update to the nodes below me. And even then, we only push it down to our direct children so that we can defer this this work of setting everything in this subtree for a later time when we actually know that we'll need it. And that's why we call it lazy, because in a sense, we're kind of putting off the work till the last possible moment we can do it. So the problem with this is that dealing with dirty nodes is really annoying. And trying to facilitate and trying to work with nodes that are dirty and maybe your children are or are not dirty, it's really confusing. So the invariant that you use is to say that every time you enter a function, the first thing you do is to make sure that your current node's value is not dirty, and that your children's, even though your children might be dirty, their range tree values are correct. So that means that for you, your dirtiness, you're not dirty and your M is set correctly. And for your children, they might be dirty, but their M still has to be set correctly. I think that's the invariant. Invariant. First thing you do. Make sure you and your children's M is correct. Make sure you aren't dirty. Wonderful. Okay. So I usually call this clean because I think it's funny. Okay, what are we doing here? We have to set... We have to do that. Well, first, you have to check if you are dirty. Because you only need to do this if you are dirty. I'm kind of lost. So if you are dirty, oh, then you need to set your children. So if not, if L doesn't equal to R, so you have to be not a child. Is that even necessary? Because the only reason that you can be a child is... I don't think it makes a difference. So if the dirty value is set, that means everything in this subtree has been set to that value. So that means you should set your children's new minimum in their particular ranges to also be the same as the dirty value, because everything in those ranges are now the same. Which means that you should do this last. Oh, but only if you have children. But I guess that's really just the same as saying that your value is dirty. Or is that even necessary at all? Seems fine to me. And similarly here, you also have to call clean. And the rest of your query is pretty much the same, because all the values that you're accessing, M and your children, their values of M will be correct when you get to them, because the first thing you do is you always clean before anything happens. Which operation are you using to do lazy prop? because it seems that you're implementing range set. Yes, this is a range set. The update is set a range to a particular value. Oh, have I messed something up? Let me put the chat back over here. Because you can't set LCM without ensuring that its subtree is all set to dirty. Should set LC dirty. Oh, that's right. I completely forgot to push down the dirty values. What am I doing? There we go. I think you have to do both, at least in the way that I have my invariant set up. Like, my invariant is that, my invariant is that your dirty value should, even if you have a dirty value set, your value of m should always be correct. Oh yes, and I should unset the dirty value. That's a good point. Dirty equals max. Which means I should also do that here. That seems about right to me. So I assume this implementation is correct now. But you set M in your clean routine, so it's not necessary to put the dirty value down. Yeah, that's fair. I think in this particular instance, for setting a range to a particular value, it doesn't really make a difference. But I think in general, you do have to do that. At least in the way that I visualize range trees. It's a good point, Genevieve. This is what I meant. Wonderful. Yes. Okay. I think this implementation is now correct. I don't think I have an example problem to test this on though. Oh God. Oh, there's so many problems. Okay. It isn't correct. Is it still broken? Try to do some subtask of lazy update. That's a good point. I can do that. Well, we can at least see if it works on Mintree. Not that it really tells us much. Oh, it doesn't compile. Oh no. What have I done wrong? Right. I buy it. What could go wrong? Isn't the lazy... Oh, it's all incorrect. What a surprise. Surely just do some subtask of lazy update. Wait, where was... Someone was complaining about how it's not correct. You just say m equals dirty and dirty equals max outside of the L doesn't equal to R statement? Here? Oh yeah, that's true. You should unset dirty regardless of whether it's a leaf. And set m equals dirty above it and dirty equals max below it. Yeah, sure. I don't think it makes a difference in this particular case. no. Oh no. It doesn't work. What do I do? Should I just give up? Let's see. What have I messed up here? You set M to max. You set 30 to max. If L is... Oh, that's a leaf. Alright, seems fine to me. Okay, so if this value is dirty, then you make your children dirty and you set their min and max values to be that. Is it in update? Oh, shouldn't I be setting M here? I didn't maintain the invariance that I said I would maintain. I buy it. Oh, that's a relief. Okay. Well, I guess we don't know for sure until we see the updates. Okay, wonderful. There we go. Wonderful. So I guess the lesson there is to make sure that you actually maintain the invariance that you said you would maintain. But yeah, I guess this is in general how I would implement a lazy update range tree. You can kind of implement what is basically a not lazy update range tree and then just kind of bootleg in this clean and dirty values in afterwards. At least that's how I tend to write them. Let's see. I could also solve that specific subtask of lazy update if people want to see that. Is it much of the same? What are the queries they want? Set all elements of the array. What is the query? Oh, set and max. Okay. That's pretty much the same. So I just need to make every value negative as I put them into the array. So I don't need that anymore. It's still ending Q. The number's still 1 indexed. No, there's 0 indexed now. So for each operation, if it's a set operation, no, if it's an M operation, then we do that. And we want to make it negative. Otherwise, if it's an set operation, then we want to set... Oh, you have to read things slightly differently. That's kind of annoying. Okay, fine. In... What is the order? Set I'm gonna just guess that it's that. And here it's negative V. Seems approximately correct to me. But the only difference is now the default isn't max anymore. The default is 0. M equals 0. And what is the max allowed? 100,000. Wonderful. Oh, but I'm not going to be able to test it on this. I mean, what could go wrong? I buy it. Everything could go wrong, apparently. Did I really get this wrong? I mean, do people actually want to see me try to finagle this? I think it's just going to be like 5 or 10 minutes of me working out what I've messed up in the input format. Or should we just move on to something else? I feel like we can move on. Did he do range add? I would rather like to know how to do range set. Isn't that what we just did? Okay, I can show you how to do range add. You have to do both in the question. Oh, okay. Is it that you want to see me code a range add operation? Is it that you want to see me code this particular problem in full, including all 4 operations? So what did you want to see when you asked about range add? Or how you combine operations? That's a good question. I don't know, actually. Let's think about it. So typically when you do set, what operation do you facilitate? You need to facilitate max and total sum. This is just snake subtask 1. What is snake? No, okay. Well, okay. I mean, my impression of the problem is kind of like something like this. So what actually do you need to do? I guess you have more than one dirty value. One for sets and one for range updates. Yeah, something like that, I guess. So it would be something like dirty add in dirty set. And this indicates that then you have to store the order somehow, right? So if you have a set operation and an add operation, you know that the set had to have come first. Because if the set came second, that would override the add operation, I think. So your cases are either set came first, then an add, or add came first, and there is no set. Because otherwise, if you add and then set, then it's like the add didn't happen at all. Maybe you just add k to the set value in the range tree. Override with set. Yeah, I think that could work as well. I would believe this is a kind of problem where there's a few different approaches. You just need to find a way to be able to facilitate both operations. Like the only complicated logic I think you have to do is to be able to figure out what effect the add and the set actually has. A combination of adds and sets actually has to the total sum of a range and the max of a range. Because if, let's say, like, you know that the dirty value is, I don't know, dirty add is, I can't type, is 3, and dirty set is 1. Oh yeah, that's a good point. Maybe that is a lot cleaner to just be able to say, if you set and then add, set 1 then add 3. It's almost as if you just did that and had no add. I actually like that approach a lot better because that means that you're guaranteed only one of these two set at a time, which I think is a nicer invariant than one of these two conditions is true. But yeah, I think that the structure is pretty much the same. You just need to push down things as appropriate. What happens when you have add x? Then it doesn't really work if you only have dirty set. Yeah, I think this is one of those problems where the goal is, it's more of an implementation thing than it is an algorithmic thing. You just have to make sure you get all of the cases right. When you have to add, you increment max. When you have set, you set max. So how the hell do you do the demerge problem I linked above? Demerge problem. This one? Snake? Oh gosh. Is this supposed to be a difficult problem? I feel like it's something that we might want to come back to later. Okay, so I guess, are people generally happy with how to implement a range tree that can facilitate range operations using lazy update? Like, I think the most important thing for you to get out of this, I guess, is here is how you would code it. And if you can implement this one time on your own outside of, say, an exam, and it took you like 3 hours, then the next time you do it, it'll take you less than 3 hours. And the next time you do it after that, it will take you less than the amount of time it took less than 3 hours before. And it does come down to a practice thing. Like before, when I said I've done like 3 range tree problems in my life, my guess is probably at this stage, I must have written something like 50 range trees. So, yeah. And still I managed to get it wrong, so clearly I need to practice it more. But yeah, just practice. I can definitely share this code. I don't know if I can put it on the /notes page because that would involve me trying to find out how to do that. And God knows I don't want to touch Aurak I want to touch Aurak as little as I can. But yeah, I can definitely send some of this stuff out. Although I really messed with this one. How much can I undo? Oh, I've undone too much. Blah, 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 blah. Okay, I think that's an okay state. What is ACOG? Oh. Oh, dang. That's real cool. Oh, dang. That's awesome. What the heck? It's just Chikingi. Oh, there's some other people. But they solved crappy problems. Oh, maybe that problem's not crappy though. Okay, anyway, I'm getting sidetracked. Okay, so if people are happy with implementing a range tree, let's move on to something else. Where is that form that I had? Explaining sweep lines with range trees. Alright, I guess I can do that next. Okay. I need the whiteboard app, I guess. Where is that? Where did I put it? Oh god. Probably can't show that. Oh, it was hidden behind one of these, wasn't it? Okay, whatever. I'm sure I'll find it again. Oh, I can't do that. Control find. Is it mapping Neptune? Yep. Where is the chat? There it is. Okay. Alright, has everyone seen this problem, mapping Neptune? This is like the quintessential sweep line plus range tree problem. Yeah, I guess I'll briefly explain it. It's pretty simple. You have a bunch of rectangles in the 2D plane, and you want to know the total area that all of these rectangles cover. So it's a pretty simple problem. So in this case, I would say the total area is probably something like 50, 60 square centimeters. Okay. So the idea is actually pretty simple. Which one is the line? Is it this? Yeah, okay. So the idea behind sweep lines are pretty simple. We're going to draw one really long line, and we're going to see what happens, how this line and these rectangles interact as we move this line to the right. Can people actually see my mouse, by the way? Is that something that I can use? The EdSet range tree one was lazy updates. Okay, so as this sweep line thing moves to the right, it starts to overlap with different sections of different rectangles. So for example, by the time you get here, you can see that the total bits that get covered are like this bit and this whole bit. And as the line moves along even further, maybe here, oh, the color is different. Maybe to here, then the area that gets overlapped is now this. So the idea is that you can kind of work out the total area that gets covered as you go by seeing the total area that gets swept out by this line as it moves to the right. So for example, when I move this line from here to here, if this gap here is like 1 unit, then, and the total like coverage of like this and this all together is say 15 units, then we know that the total area here is 15. So as this line moves forward, you can kind of count the total area that gets covered. Everything's up to 30,000. Right. So does that basic idea kind of make sense? The only kind of trick is that there's a lot of details that you kind of have to get right. So I guess there's two parts. Firstly, you need to be able to maintain like the sets of ranges that are covered as rectangles enter and leave the sweep line. So that's one problem. And then the second problem is, oh no. The second problem is actually working out how much distance gets covered as you go. This one is less how much distance gets covered as you kind of move your sweep line along. This one is not as difficult in mapping Neptune because the bounds are quite small. The rectangle's coordinates are up to 30,000, so you can afford to just very slowly shift things along by 1 unit at a time. Okay, so how do you actually address problem 1? So we're discussing range trees, so we kind of want to turn this sweep line into some kind of problem about updates and queries. Should I clear this? How do I clear this? Where's the clear button? That is not the clear button. You know what? There we go. Okay, so the query is pretty obvious. What is the total area? Yeah, what is the total distance covered by the sweep line? The moment. So that's like if you had something like this, I guess, and your sweep line was like that, then the total area would be this and this and this. And so the update is, this one's a bit more complicated. How do I want to draw this? Yeah, okay. Yeah, so as your sweep line moves to the right, there's kind of two things that can happen. The first is that you move to the right and a rectangle that was intersecting your sweep line ends. So kind of this range disappears. And the other one is when there's a new rectangle that's going to enter your sweep line. So it now covers this area here. So those are the two events. So I guess I'll just do it here. Update 1, add range, update 2, remove range. Do I want to phrase this as add range? Let's say this is increments and decrements. increment range and decrement range. So they're kind of the same thing. Although, is that more complicated? I'm not sure. What do I actually do for this problem? Have I solved this problem? I have solved this problem. Please zoom. Can I do that in this app? Why, yes, I can. Oh, okay, I can do it like that. Where's the drag button? There we go. Yeah, I don't really like this particular interpretation. I think I like the other one. Where is... Okay. No, this is more like update 1. Add range to range tree. Remove range from range tree. Yep. Okay, so I don't have enough munches to watch Kevin have the chat up. And code. Wow, multitasking. Okay, so these are the 3 operations we're trying to facilitate. And if we can do this, then that means that we can keep track of the total area that's being covered by the sweep line as we move it. So the idea is pretty similar to what we had before. It's quite similar to the lazy update idea, but instead of setting a dirty value to represent work that needs to be done later, you're kind of just using the dirty value to say whether a given range is or is not covered. I don't know if that makes sense, but like maybe it's easier to see in code. Yep. Oh my god, what am I doing? Okay. Yep, so instead of having... Okay, so this time M represents the total area covered in this node. And this time, instead of calling it dirty, I'm just going to call it covered. Well, maybe we're like covering ranges. So this tracks the total number of rectangles that completely cover this range. So what actually changes here is how we keep track of these values. So so when we add a new range, this becomes like an add. I don't think this invariant is useful anymore. Yeah. I don't think we actually do any lazy things with this problem. I don't think. Yeah, so if it misses the range, we don't care. If it's partially covering, then we want to set that So that means that one additional range is now covering this entire thing. And otherwise, we just perform the update on our children. And I guess this is kind of complicated. So I'm going to write a new function to deal with this. Void update. So if covering ranges. So if there's at least one range that covers this, then my value should now be, my M value should be now R minus L plus 1. Assuming this is inclusive. So this just means that because there's at least one range covering me, then that means that it doesn't really matter what things look like for the nodes below me. I think that's what we want. Otherwise, you just do the standard thing, which is that M equals so if you're not covered by any ranges, then you just check the total coverage of your left side and your right side, and you can add them together. And come to think of it, this is probably the same for remove as well. So if we just change this to a V, then we should be fine. So if you want to add a range, then you just call add, well, UR1. And if you want to delete a range, then you just call add UL UR minus 1. Yeah, I think that's a general idea. And so we actually don't even need a query function of this problem. We just need to check the root node. So your query would look something like RT M. Yeah, this would give you the total coverage. So I don't think you need this function at all. Yeah, I think that's it. I don't really want to code the rest of mapping Neptune. Is that something people would actually want to see? Nah. The non-trivial part. They haven't heard mention. What is the non-trivial part? Is that each node isn't globally accurate. I'm not sure what you mean by that. Yeah, okay, I guess this is a distinction that's true. So typically with a range tree, every node so like I guess one thing that can happen with this particular range tree is that so these are your range tree nodes. Oh, there's not enough nodes. Okay. And so let's say that you add a new range and it covers like this, covers this area. So what ends up happening is you end up coming down to this node. You realize that this range covers the entirety of this node. So here you set covered equals 1. And in these nodes below, covered is still 0 and M is also 0. So one thing that's kind of unusual about this range tree is that this node's value this node's value here is actually not correct at the moment. Now, for this particular problem, because you only ever care about querying the entire range, this is not a problem because this node's value is always going to be correct. Because whenever you do an update, it always ends up touching this node, and that's fine. It's possible to, even though not all nodes in the tree are accurate, it's still possible to do range queries and have them still be accurate, but it involves some extra work on your part to actually put the pieces of the query together. So as you're walking down the tree, you kind of have to keep track of what nodes, whether there's a node in your path that you've taken that's actually been covered. So if you were actually to query just this node here, as you're walking down the tree, like you would need to keep track of the fact that there is a node that has been covered completely for you to get an accurate query. That is a detail that is a bit difficult in this problem, but I don't think that you have. It's a detail that's a bit difficult in this style of range tree, but I don't think you have to deal with it in this particular problem. Is that what you wanted to get at? Yeah. Segment tree node info. Yep, that's a very concise way of putting the amount of information that you need. In fact, I'm just going to steal it. Wonderful. Okay. So I guess the more important thing that I wanted to get across with this particular problem is how you actually use the sweep line to solve this problem. It's actually kind of interesting that the actual range tree that you have to use itself is also kind of unusual. Yeah. So the other problem that I wanted to talk about when discussing sweep lines is number of distinct elements but offline. I guess firstly, do people have any questions about this mapping Neptune problem? Sounds like there are no other questions about this, so I will move on. Okay, so the other problem I wanted to talk about is you're given an array. Oops. How do I... You're given an array, so maybe it's something like this. I don't know. And then... How do I make this bigger? Oh, there we go. Why? Oh, that's a weird interface. I have no idea what range mix query means. But yeah, so the next problem is you're given an array and you need to facilitate queries of the form how many distinct elements are there oh god, are there in the range LR for different L and R, and it's offline. So does the problem make sense? So for example, if you're being asked about, where's the color? If you're being asked about this particular range, there are 1, 2, 3, 4 different elements. The 3 appears like twice, but we don't count those. So the way that you solve this problem is you realize, oh, the problem is offline, so maybe sorting the queries helps. So the idea is kind of like this. Like if you draw out all of the queries, like maybe the first one covers this range, maybe the next one covers this range, this one covers this range, and so on. Then if you have like a sweep line that starts here and moves to the right, then maybe you can answer queries. Then whenever your sweep line kind of gets to a new point where a query starts, then maybe you can answer that query. And the reason that might be useful is because that means that if you're going to maintain some kind of structure as you sweep across, then every query that you end up doing on this structure is going to be from some kind of prefix. So like all the queries that you have to answer when your data structure is up to here, they all start there. And when you move it along then and get to a new query, maybe that one. Oops, oh, I'm mixing rectangles and lines. Then you can answer that one as well. You still have to do count number of elements greater than x. The problem is to count the number of distinct elements in the array, in the subarray of the query. Okay, so the idea is kind of like this. Let's say we consider the problem when like, let me think of a good example. Yeah, maybe something like this. Yeah, so let's say we look at all of the queries that happen to have L equals 1. So that means they all start here. I picked the wrong color. So what kind of happens as you look at the endpoints of the queries as we go to the right? So like there's one query, there's a next query, there's a next potential query, and so on. What actually happens as we extend the right end? Yeah, so when you extend the interval to include this number 1, that's like a new number, so that's good. When you extend it to include number 2, that's another new number, so you add it to your total. When you extend it again, you add another new number, and that's a 3. When you extend it again, then this 2 is a number that you've already seen before, so you don't end up increasing your total. Now when you extend it to include 4 and 5, those are numbers you haven't seen before, so that increases your total. And for this 3, that's a number you have seen before, so you don't want to include it in your total, and so on. So what you can kind of do is you can kind of build a secondary array. This secondary array looks a bit like this. It's going to be a 1 when it's an element that you've seen for the first time. Otherwise, it's going to be a 0. This is 0. Yeah. So where these are 0, where this new array is a 0, that means that the corresponding element is one that we have already seen before. And so now when you're answering queries, it's just a question of, given some prefix of this array, what's the total sum of elements in this particular prefix? Does that idea make sense? Oh God. It's hard to tell if the discussion here is related to what's being discussed or not. Okay, so it sounds like people don't have questions about this idea. Okay, so now that we've established a way to answer the queries where everything is a prefix of the array, the question is, what actually happens as we sweep? So what actually happens when we move along? So when we actually shift this array forward one, so maybe to here, all this really means is that nothing has kind of changed, right? Like the array is still pretty much the same. So I guess this element here, it's one we're never going to query again, because all of the queries from here on out either start from here or somewhere further along. So whatever this element is, we don't really care anymore. So that one's not particularly interesting, but let's say we move it one along again. So now that the query is up to here. Again, we don't care about this element, but we notice now that this 2 here, it was an element that was repeated before, but since we've actually gone past this 2 here, that means that when we're doing queries from this prefix onwards in the array, this 2 is now like a real 2. So we actually end up having to update our array. So this goes from a 0 to, this goes from a 0 to a 1. So does that general idea make sense? Every time you end up shifting the starting point of the left point of the query, there's potentially an element that ends up going from a 0 to a 1 because of this. So this is kind of pretty much all there is to the problem. So even though this problem didn't really look like, doesn't really look like something that has a sweep line involved in it, because the problem is offline, the first thing you might think is there something useful I could do with a sweep line? So do you maintain a sum range tree? Yes. So in this array, the structure is, the operations you're trying to implement are query sum of prefix and update change a 0 to a 1. You could use a BIT. Yep. So this range tree is a point update range query. So there's room for simplification. So actually the actual range tree behind the problem is very simple. It's probably one of the simplest ones, the simplest range tree operations you could get. But the idea of seeing the sweep line is the difficult part. Okay, so does that problem make sense to people? Are there any other questions about this one? Is that yes, there are questions, or yes, you understand? I guess we'll never know. Okay, cool. It sounds like everyone is happy with that. Okay, I think that's all that I wanted to discuss for sweep lines. I don't actually remember if there are any other sweep line problems in the set. Does anyone happen to know off the top of their head? I'm now looking through the set. Oh, global warming, I think, is a sweep line of some kind. Oh yeah, lowering standards, that's the other one. PAMCAN retires, I think, is also a sweep line. But I think that one's a bit more involved. Trapzoids. Interesting problem. I'll write that down and see if I can find it. Although I guess probably you shouldn't be randomly betting problems like this. Because if we do end up using trapezoids in an exam, then people will know it's a range tree problem. But yeah, if you want more practice with sweep lines, lowering standards and PAMCAN are problems that you have access to that are really good. Okay, what was the next thing people wanted to discuss? How do I keep losing all these tabs? So one unfortunate thing about the setup I have is I have two monitors, but they're different resolutions. One's a 2K monitor, the other one's a 4K monitor. And so trying to get them to display at the same resolution is kind of difficult. I had to do some weird hacky things. I have like a short procedure they have to follow in order to get things right. And one of the steps is to open the NVIDIA settings app and leave it open. And that's all they have to do. I don't have to change any settings. It just needs to be an app that's open when I do the other things I need to do. But turns out trying to stream things with OBS breaks it. So I'm just back to having my second monitor have really, really tiny text. No, unfortunately not. My my refresh rate is still only 60. The only games I really play these days is Dota. You don't need high FPS to play Dota, do you? What was I looking at? Okay, I've explained range trees, explained sweep lines. How long did I say I was going to stream for? I don't remember. Okay, I guess I'll just keep going until people die. So, oh gosh, I've been streaming for 1.5 hours already. Okay, how about I stream for another 20 minutes? And we'll take like a half an hour break. And if people want to come back and discuss things I didn't end up getting to, then I can do that. Okay, I guess I'll just open up to the floor. What do people want to discuss next? I had more complex range tree operations. I had DP with range trees. I could discuss more problems in the problem set. Actually, we did a bit of that. Or I could discuss problems that are not in the problem set, which I've also done a bit of. And just general Q&A. It's like, just what do people want? Maybe problems that aren't in the set. May we please do nested DS if that's on syllabus? So the thing about nested data structures is that it's not on syllabus. Even though it's, I mean, some data structures you can think of as being nested, but it's something that's being excluded. So yeah, it's something that I might talk about more. I might talk about more off syllabus stuff later in like April camp in quotes. But I wanted to get through all of the kind of core content first to make sure that everyone is like, they have like the base level of knowledge to be able to do all the informatics-y stuff and the selection exam. MP3 player is a really, really good problem. But the thing about that problem is that I don't see a reason to burn it. Because it's kind of like once you see the idea and once you've, like, even if I just explain the idea to you, it's kind of not really something I feel like you can apply elsewhere, if you know what I mean. Like, it's just a general test of your ability to solve problems. So I'd rather not burn that one. Yeah, if you want a really amazing range tree problems, you should solve MP3 player. It's very nice. Okay. There's like a lot of advanced range tree things being requested. DP with seg trees, lazy create. Oh, that's a good point. Lazy create, I don't have a problem in the set for lazy create. But I can explain that one really quickly because it's just a very short change to the lazy update code. Oh god, it's all ruined. Okay. All right, so the idea with lazy create is when you want to build a range tree over a range that's like incredibly large that it doesn't necessarily fit in memory, then you can't, when constructing the range tree, build up every node. So what you end up doing here yeah. So when you create the node, by default, you set your left child to be null and your right child to be null. And just like lazy update, every time you want to call any of your functions, you have to make sure that the nodes, your children exist. So in addition to clean, we have a make babies. And you do that for all of your functions. And all that this does is it does this. So if LC equals null, RC is null. If one of them is null, both of them should be null, but I want to be really explicit about it, then you just do this. This is not the correct order. So you only need to make babies if you're not a leaf. If you're a leaf, oops, if you're a leaf, then you can just return. Oopsie daisies. Otherwise, what am I looking at here? What have I, yeah, okay, there we go. Yep. So what this does is every time, this should be a void, every single time you call one of your functions, you'll guarantee that either children already exist for this node or they'll be made. The only thing you have to be careful about when you make them is that you have to initialize them with the correct values. And the nice thing about implementing range trees using a struct and using constructors is that it's not possible to forget to initialize something, because the moment you call new, the constructor gets invoked and all of these values will be set. And this shouldn't be capital N and capital R anymore. These should be this node's values. Yep. Okay. So So that's genuinely all there is to lazy create. All you have to do is to, instead of making the nodes, all of the nodes up front, just only make them as you need them. It's really that simple. And the reason this saves you memory is because even if a range is over a node with like, a range tree is over a billion elements, you aren't going to get a billion queries. So a lot of the nodes in the range tree are going to go unset. The only thing that might make lazy create a bit more difficult is that the default value isn't always something simple like 0 or int max. But in that case, it's not too difficult to figure out. I think that's something you actually have to worry about with Mountain, because Mountain is one of the problems where you need a lazy create range tree. Oh, that's actually a good point. So the thing about lazy create range trees is that sometimes you actually don't have to do them lazily. I pretty much always go the lazy create route because I just find it really simple to do. And it's kind of the same process for every problem. But the other way you can get around this is if the problem is offline, you can kind of just look at all the queries and updates and see what values are actually present. So for example, if you know that no numbers appear from like, if no queries ever touch, that's not strictly true. But like if you know, let's say you have a query that's like from 10 to 300, and you have an update that's like from, that updates element 5, another update that updates element 8, another query from like, dude, I don't know, 14 to 17, you kind of know that between 17 and 300, like nothing interesting ever happens. You never get any queries or updates that include some of the elements in that range. It's always all of those elements or none of those elements. So what you can kind of do is you can kind of rescale everything. So, what's the best way to do this? You can kind of rescale everything. So like 5 is now the new 1, 8 is now the new 2, 10 is the new 3. Oh God. 14 is new 4, 17 is the new 5, and 300 is the new 6. So you've kind of compressed everything down into these values, and that's as simple as just taking all of the different values that occur, sorting them, and then assigning numbers from 1 up to n or whatever. The tricky bit now is that you have to remember that this 6 actually represents like 300. So when you're doing any operations that's like, oh, I want to set everything in the range 5 to 6, I want to increase that by 1. That's really setting something like 280 different elements. So you might have to do a bit of finagling with maths to get that right. This is part of the reason why I want to avoid doing this compression technique where possible. This is called coordinate compression, by the way. Doing this compression where possible, because I feel like lazy create is just so much easier to think about. Lots and lots of memes about babies. So lazy create doesn't necessarily improve time and space complexity. It definitely improves space complexity because you don't have to build the entire range tree at once, and because the number of queries is typically a lot less than the number of elements, that can save you a lot of space and time as well, because you don't have to build all of those nodes. Okay, I think that's lazy create explained. What other things did people want? Segmentary beats, that's a really cool topic, but it's one that they only sort of understand, and therefore I'll do an incredibly poor job of explaining it. If you want to I think Ericto made a really nice video about segmentary beats. You should just go learn it from him. Segmentary beats is like a advanced range tree operation that you can do using some pretty cool tricks and some nice amortized analysis. I would say it's an advanced topic though. We can learn it if you're interested. Is secondary beats out of syllabus? I don't know if it is. I don't think it's technically out of syllabus. Based on my understanding of the technique anyway, there's nothing that excludes it from the syllabus. But it's something that I could believe would reasonably appear in an IOI. Okay. So there's like 10 minutes left before we go on our mandatory RSI break. So I guess I'll just shift it over quickly to Q&A for 10 minutes, and then when we get back, I can discuss DP problems with range trees. Does that sound good? Oh, I completely forgot to tell Angus that I was doing this. I literally Googled Angus. What's wrong with me? Is Selm going to be 2 days? The answer is I don't know. Currently, this is nothing that's set in stone yet. But we're currently preparing one selection exam. But it remains to be seen, I feel like, if we want to do 2. So I mean, the problem is that with April Camp in person, like you're kind of trapped at April, so we can kind of do whatever we want with you. But when you're like, at home and stuff, forcing you to kind of have 2 days where you have to block out 5 specific hours of time, it seems like it might be more difficult. And I feel like if we can be convinced that a single selection exam is sufficient, then I think that would be a lot better for you all than having to, just do lots and lots of sitting at home. We have no life, it's fine. I'm sure it's fine. Wow. I can't believe that you actually want to have more exams. Can someone give me a link to the stream? Why is it so hard for me to figure out how to find it? Nope. Classic. Oh no. There's like a billion links to the stream. Sorry, completely forgot to let you know. It's recorded though. Okay. Thank you. Requests processed by several babies. I don't know how I feel about that. You know what? All right. Are there any other cool range tree things that I can talk about? Oh, I guess one thing I can talk to you about is post-order traversal. That's a quick thing, isn't it? Okay. Oh my god. That's a good point. I don't think there are any post-order traversal problems in the set, are there? Where did the... I've lost the page with all of the... There you go. feel like my computer is starting to slow down a bit because I just have like a billion Chrome tabs open because I keep making them and then being unable to find them without revealing all the Chrome tabs I have open. What if you see like a random Wikipedia article that's like A.O. Karasik? Won't you all think that that's in the selection exam now? Okay. Yeah, so here is a problem. You're given a tree with a rooted tree and the nodes have numbers in them. Maybe something like this. It's not necessarily a binary tree. Okay, the actual numbers don't matter, but you have to facilitate operations of the form query. What is the sum of the elements in a subtree? And you have to perform updates of the form change an element to x, for some x. So when you look at this problem, you're like, wow, that looks like those queries and updates look like a range tree, but I don't have a range to query over. It's a subtree. That's very sad. I can't do anything now. But that's not the right way to think about it. The right way to think about it is to realize maybe you can turn this into a tree. And it turns out the answer is you can. So let me redraw this tree in another way. There. Yep. Yeah, so maybe I draw it like this. Did I screw this up? Maybe. Okay, so this is the 7. This is that weirdo 3. This is that 4. This is that 5, whatever. Okay, so now that I've kind of redrawn the nodes like this, the structure is the same, but kind of the order from left to right, I've kind of messed with that a little bit. So you'll notice now that, let's say you look at some range, maybe this one, you'll notice that it actually forms a contiguous block of nodes in this particular order. I know this diagram is really ugly looking, but hopefully it gets across the idea. Every single one of these subtrees corresponds to some block. Corresponds to like a consecutive group of nodes. And you can verify for yourself that this applies to every subtree. So for example, this subtree, that's this block. So the lemma here is that for every rooted tree, there's a way of giving a numbering from 1 to n for these nodes, such that every subtree consists only of a block of consecutive nodes. And once you've done that, you can kind of turn every problem about queries on subtrees and updates on subtrees into queries on ranges and updates on ranges. That is the post-ordered traversal trick. And the reason it's called the post-ordered traversal trick is because the traversal you're looking for is the post-ordered traversal. Why is this so strangely explained? But yeah, the post-order traversal is really simple. It's, you do a DFS and you go to your left node, you give them all numbers. You go to the right node, you give them all numbers. And then for your current node, you just give it whatever the next number is. So in this particular example, this node will get the number 1, this node will get the number 2, and this node will get the number 3. I think there are other traversals that work. I think in order is one that also works, and probably pre-order as well. In fact, probably every order works except for the in-order traversal, this one. So I don't know why it's named after the post-order traversal in particular. But yeah, if you apply this numbering, this DFS numbering to the nodes, you can turn every subtree query problem into one on a range. In order isn't defined for non-binary trees. Oh yeah, that's a good point. Yeah. But yeah, that's the idea. Okay. We have now hit 5 p.m. my time anyway. I'm going to go duck out and grab some amount of food and then return in half an hour where we can do things. Should I end the stream or should I just leave it running? Oh, but I can't even end the stream, can I? To end the stream, I need to find the tab with the stream open. But I can't do that. Oh, I can just end the stream on OBS. Ah.